towards the 4-bit parallel in parallel out shift register. Here again you can see the title parallel in and parallel out. So we have to give the input data as a parallel manner and we should get the output in terms of parallel manner. So here again for 4-bit data transfer or 4-bit data storage or shifting of the data, we require 4 D flip-flops connected in a such a way that we will get the parallel input and parallel outputs. Here you can see common clock is given to all flip-flops. 4 D flip-flops are connected. Inputs are given through these D input sides from 4 these flip-flops, and output we will get in terms of QA, QB, QC and QD from these 4 flip-flops. Now this operation of this parallel in and parallel out is very simple. Here we have to remember one thing, that whatever input I am giving through these 4 input terminals, immediately that will reflect as an output through and in a parallel manner. As we know that in the D flip-flop, if I am giving 1, it will immediately store the information in the flip-flop as a 1, or it can transfer within one cycle 1 towards the output. That is, we will get at Q side 1. If I want to store or if I want to transfer 0 from D input side, immediately it will give output as a Q. In different flip-flops, for example JK and SR, there are different types of states like set state, reset state, again no change condition, toggle condition. For that conditions, we cannot use these type of flip-flops here in the shift register. Here we can use only data D flip-flops, so that we will get whatever input I am giving to the input side, we will reflect as a output side. So here I want to transfer, for example, say 0101 information through this 4-bit PIPO shift register. For this case, you can see the inputs are A, B, C, D terminals and outputs are QA, QB, QC and QD. So there are 4 different terminals at input side and 4 different terminals at output side. So at a time we have to give these 4 bits through this all input sides. So 0 will be here. For example, if I am considering 0101, so I should give the input as the first MSB. This first flip-flop we can call as a MSB, because whatever output I am getting here will be reflected. First digit means it is MSB. So this is 0. I will transfer this 1, then 0 and this 1. So I have written only whatever bits I have to transfer, I have written as a input sides. So previously if I consider I am not giving clock pulse, so what will be the output? QA, QB, QC and QD. What will be the output if clock is absent? Clock is absent, it will be 0, 0, 0 and 0, though the input is given. But if I am giving this type of data 0, 1, 0, 1, so with the clock pulse high means rising. This is the rising clock pulse. If I am giving for this clock pulse, if this 0, 1, 0, 1 data is given to the input, it is given to this flip-flops and reflected in terms of Q is nothing but the output of each flip-flop. This Q is taken out. So I am transferring here for first clock means first cycle or first pulse. This 0 is input given, then 1 input given, then QC 0 and last is 1. This all data is, you can see DA, DB, DC and DD means last flip-flop. These are the inputs given. See, immediately it will transfer to the output side, means we will get immediately or instantly this whatever input data I have transferred or given to the input side. So 0, 1, 0, 1 we will get immediately or instantly at the output terminals. So the main difference between this 4-bit serial input serial output shift register and 4-bit parallel in parallel output shift register is that while transferring the data in the SISO, the number of bits require number of pulse or gate pulses. For example, to transfer 4-bit data, we require 4 positive rising gate pulses to transfer the data. So we require here 4 pulse rising pulses like this one. So 4 pulses we require, because for each pulse it will transfer only 1 bit to the next flip-flop. This is the part of SISO. But in case of PIPO, only single gate pulse is required to transfer number of bits. For example, if I want to transfer 16 bit data, here we require 16 flip-flops in this connection, but 16 bit data can be transferred within one positive or rising pulse gate. This is the main difference between shift register, SI, SO and PIPO. This shift register we can see in computers, in calculators also. If I am giving the input 1, if I press 1 and if I want to press one more another digit, that previous one will transfer to the next or it may transfer to the left, like this discussion. So here these are the different applications which can be used in computers, in a processor or in a digital electronic circuit.